Hello and welcome to our presentation, code coverage for embedded targets. Still some people are not joined the meeting yet, so we will start. And anyway, for the general presentation, I think people will join us afterwards. My name is Olivier Cass, and I will today animate this webinar that will roughly last 40 minutes. And with a demonstration and a 5-minute questions and answer session at the end. During this presentation, we will show you what code coverage is and why it should be measured. We will explain different coverage levels and the requirements of the ISO 26262 as an example. You will see how coverage is measured with Testwell CTC++, the leading test coverage analyzer for embedded software development. We are Testwell product line 2's vendor, including our leading Testwell CTC++ and distributor for complementary solutions for most European countries. The EFASoft headquarters is located in Offenburg, not far from the French border, and we do have a number of distributors worldwide. We are experts in validation and testing and provide solutions and services in the software test domain for their management and quality assessment through code coverage, and this for more than 12 years. Code coverage shows you all parts of your code, whether they have been tested or not. In this picture, the blue branches have already been tested, and the red one not yet. In order to achieve 100% test coverage, we need to test the red parts of the code. So why measure code coverage? With code coverage, you can write adapted test cases in order to cover the parts of the code which are not yet been covered. Code coverage helps you to avoid redundant test cases and save time and money. You know when you can stop testing. The goal is achieved when the requirement test coverage has been reached. Code coverage is also a proof of quality for your customers. And if you subcontract development or testing, the coverage report shows you the amount of test. Code coverage tools helps also to find dead code, which is not a good idea to let any dead code in your application. And for all these reasons, code coverage is required by security standards such as DO 17080, IC, EN, and ISO 26262 that we will use in a few moments as an example. Now, let's have a look to the different coverage levels. And on the bottom, we have the function level. 100 function or code coverage is achieved when each function has been executed at least one time. This is a very low coverage level. On top of this, we see the statement coverage. To achieve statement coverage, all different statements within the function need to be tested. And more detail, branch coverage shows which branches within the statements have been tested. The highest coverage level requested by security standard are shown on the right side of our picture. Here, each condition needs to be tested. A very important coverage level for security critical is the MCDC coverage. MCDC stands for Modified Condition Decision Coverage. ISO 26262 is a standard for automotive industry for the functional safety of road vehicles. The required code coverage depends on the ISO level. ISO stands for Automotive Safety Integrity Level. So in those two tables, you will see that, for instance, ASIL A only statement coverage is highly recommended. Here is the text description. And for ASIL level B, the higher level branch coverage is required. For the highest level is D, modified condition decision coverage in CTC need to be achieved. To show and prove that you have achieved the requested levels, a good code coverage tool like Testwell CTC++ is needed. The technology we use is code instrumentation. So Testwell CTC++ use this technology where the instrumentation adds global counters in the source code. Each time a part of the code is executed, the corresponding counter is incremented. Then the counter values are stored, and at the end, or on demand, the coverage information is shown, as you will see later on. Here we see the process, let's say the classical process of unit testing without test coverage. So you have your C source code files, here is the compiler, and then the object files that are linked in order to produce an executable to run on your target. So here is an image of the memory requirement without instrumentation. And here we have to the process the instrumentation, so in let's say blue-gray color, and at the end the ripple generator, which is key, and it takes two files basically. One which is a symbol data, so all symbols used for instrumentation, and the other one which is the values of the counters stored in this data file with all the counting value, and then it will produce a report at the end. So as you can see here, the need for requirement with instrumentation is a bit higher. So this is in some situations something which can lead to not be able to put instrumentation, and with our experience we can say that for 80% of the lack of memory it's due to RAM, and for ROM it's about 20%. So RAM is quite critical for instrumentation and code coverage. Another reason could be that the target doesn't have any link to the host in order to store the counter value and to produce the data file. But I think any kind of target should have a debug interface, so we can reuse a debug interface such as RS-232 serial interface or Ethernet or whatever means it's available. And in spite of the low memory need for Testwell CTC++, even if your available memory space is too low, we can use a very specific optimized technology that we call bit coverage, which is an add-on to CTC++. With this add-on, we don't count anymore how many times a piece of code is executed, we count only if it is executed or not. And then, as you can see here, we are using only a few bits in order to have this information available instead of bytes or words, complete words with classical approach. So this is a very optimized approach, well known in the automotive industry, where any bit saved will save a lot of money in the future. So Testwell CTC++ this way can support any coverage levels we have seen in the security standards, so function coverage, decision statement, and the MCDC that we just talked a bit about. The good news is that it can work with any unit testing tool available, including free or commercial toolsets. Here is a list, and on the second page we also have another list of available compilers, but there is no reason CTC++ couldn't support your compiler. We do have customers using their own compiler for very specific microcontrollers, for instance, let's say on the credit card microcontrollers, for instance. They're using dedicated compilers, and we have been able to add them to make CTC running on those kind of compilers and targets. So this is good news, and we do say that CTC can support all compilers. We don't know any unsupported compiler so far. And this is the same for the targets. With the very low instrumentation overhead that we are using, it literally works with any target. Even very compact with a few hundred of bytes of memory, we are able to run CTC with the instrumentation at very low. About the reports, we'll see in a minute some example of reports produced. So it could be plain text, and this text, of course, could be customized in order to produce your own corporate report, or XML or HTML, in order to browse them in any web browser. And we'll see different reports. So the first one is about directories. So the files used in this could be detailed later on. So we do have in this report here what we call the TER, so the effectiveness ratio. So it just indicates on the total numbers of paths which one have been tested in your unit test vectors. So this is another one for file, where you can see per file the TER. Another one for functions. So here you have function per function, the details of the coverage, and everything can be selected on the top over here. And this one is very interesting. So this is the execution profile with a summary of what has been tested, and more importantly, what has not been tested yet. And in red, you will see the parts of the scenarios that are not tested yet in order to increase the code coverage. So we'll produce some zoom here, and you will see that in order to go further and to try or go up to 100%, we need the first condition set to false, and the second condition set true, and then we'll be able to increase that value. And we do the same here for this part, which is not at all tested yet. We propose a qualification kit for Testwell CTC++ in order to support you with the qualification process of Testwell CTC++ for your ISO 2622 projects and others, such as the DO 178C, for instance, and many other security standards. Not all are mentioned here. We support nuclear, for instance, projects. So we are taking here as an example the ISO 26262, and for certification of your project, you need first to classify the tools used, so not only CTC but the compilers and model designers, etc., and to prove that they are qualified or not. And here we need first to check if the tool has an impact on the software. In other words, if this tool can produce some problems in your application by being in the tool chain. So if the tool has no impact, it's then classified to classification level 1, and there is no tool qualification needed. But in most cases, code coverage tool has an impact on your project. So even if it cannot introduce errors directly on your code, it can fail to detect bugs, and the coverage could be wrong, and so it's a problem in your project. So that means that you need to check the probability to detect such impacts and to determine which level of classification is needed. So part of security standards, you will find also recommendation and a process in order to evaluate the qualification level, And here, for instance, in this table, we see that the tool impact will lead to error detection. And here, another table related to the ISO we just mentioned before. So the tool qualification is done by validation. So we'll provide a way for you to demonstrate that the software tools complies with the specified requirements, and we provide for this use cases of the tool in order to check it, and also that the malfunction could be analyzed and fixed, and a way to avoid or detect them. So we provide also in the kit means for this, and how the software tool could be qualified further. So this is related to the process, and for critical projects, you need first to do a tool classification as we have done, and only the critical tools need to be qualified. So we'll go a little bit further in this qualification process, and this is quite straightforward, because you have a guide in order to go to the reports generation, as we'll see in a minute. So this qualification kit is not only for one product, it covers a lot actually. Currently it supports the C language, which is one very famous language in the embedded world, and all coverage level, and MCDC, for instance, is the one you may want to target, and also report generation. Thousands of test cases, as we have seen, and it includes this, and this is detailed here. So this is a process where within the qualification support tool, we'll be able to generate documentation, which is asked by the qualification organization, the full documentation package. So we're able to produce this tool qualification plan, classification report, even the safety manual. And here there are the test plan and test script that we provide in order to check in a test automation unit that CTC++ just conform to its specification. So here is a process of how to use the qualification support tools, and you will see this is a step-by-step approach. So here you will select standard and variant of the tools, which tool you are using and its versions, the features you are using, in some cases some mitigation you want to apply, and then finally you will generate the documentation expected from your choices. So this is the result, one of the results. So you have several Word files which are generated. Here is one. This is the example qualification textual file with information available. So the goal of the tool qualification is to show that CTC work properly within your environment. Back to the tool by itself, CTC++, it supports all important, let's say, major platforms, so PC with Windows or Linux, and even workstations, the Unix-based that you used in the past, but for very long-term project, which is needed to maintain the software for decades, 20, 30 years, even more. I'm sure you know companies using still this workstation. It's available on Mac, and it could be also on other platforms if needed, or on request. We can study this with you. So the same for IDE integrations for environment development. Here you can find for PC the Microsoft Visual Studio, but also for cross compilers IAR, for instance, Bourne, Fujitsu, Eclipse, which run on a lot of various platforms. But we can name any compilers and any environment here. And these are a very short list of third-party tools CTC is integrated with. Again, this is very short list just to provide some information. So we'll be happy to help integrating with other tools. About the tool by itself, so this is a very mature and robust tool because it has been started to be developed in 1989, so quite a long time ago, and it leads to have first company leading to sell this support this product called Testwell, and in 2003, our company VerifySoft takes as a distributor the role to sell and support this tool in other countries in Europe. And 2 years ago, VerifySoft just purchased a Testwell tool set. So now we are the tool vendor for this complete tool set, and we have distributors in various countries in order to help to sell it worldwide. So it's time now for a very short demonstration about the tool. So I will prepare very quickly my demo. I hope you can see the screen. So our example is called Prime. This is an application which just determines, based on the inputs, if the number which is entered is a prime number or not. So it's quite straightforward. So I will clean up from the previous demo in order to have a clean directory. So here we can see just some source and headers files, which 3 source files and 2 headers files, and the make file in order to produce the executable. So I have 2 scripts in order to fast up the bit demonstration, and let's just use the first one. So what we're doing here, I will come back to the first line. So what we are doing here, we are just using the regular compiler command, which is for Visual Studio on Windows, like here, and make all. And it just takes the makefile that you have set up in order to produce objects and executable for Windows. So we just put up before this command our CTC wrap command with some arguments, v for variables, etc. And as you will see, the compiler and linkers is used the same way, except that we do make some instrumentation and add some files. Okay, so this is what we produce here. We just have object files and executable like we do regularly, but on top of this, we have now a mon.sim file, sim for symbolic, which includes all data related to the instrumentation in order to produce the report later on. Okay, and in order to produce this report, I put a script. In order to create, oh sorry, I'm going too fast. Actually, I need to make some unit testing before. So I will just put some numbers and try to have the best coverage possible, and 0 to exit from this program. So here now I have a file which is mon.dat, like data, and these are the counters, values where the code has been executed. And using those files, now I'm able to produce a report, which will be, in this case, HTML file. And in these files, as we have seen in the PowerPoint, we are able to switch from the various summaries available, and for instance, the untested code we have just said, or the execution profile. So you have the test effectiveness ratio, donc that we could use in order to increase to go to 100%, of course. And the values are there. We just need to compute which numbers I have to enter in order to go to 100%. But as I'm a bit late in my schedule, I will go a bit faster on the demonstration and go back to the PowerPoint slides. This is available anywhere on videos from previous webinar or standalone videos in order to show what CTC can do for you. So it's just a live demonstration I've made. So back to the PowerPoint and the CTC++. We've seen that the qualification kit supports C, but CTC++ supports more languages such as C++, and Java and Android and C# are also available. This is a very short list of some references, some customers who produce information which are available, because some customers are not willing to mention any activity because this is very sensitive on the market, etc. So here you will find some numbers from various industries. So I'm sure you will find some names which are in your domain. And for automotive industry, for instance, in Germany, we are very proud that all car manufacturers, all OEMs, most of their software suppliers rely on Testwell CTC++ for code coverage. So in order to go further with CTC++, it's possible to evaluate CTC++. We also some training, and you will see a bunch of information on our website. I hope you enjoy our presentation. Thank you very much for your time.